Welcome back, stargazers. Today, we're diving into a cosmic event that's truly out of this world, kilonovae. You might be familiar with supernovae, the explosive deaths of massive stars. But how do kilonovae compare? Let's find out. First, let's quickly revisit what a supernova is. When a massive star reaches the end of its life, it can no longer sustain the nuclear fusion in its core. This leads to a catastrophic collapse followed by a gigantic explosion, releasing an immense amount of energy. Supernovae are some of the most energetic events in the universe, releasing up to 10 to the power of 44 to 10 to the power of 46 joules of energy. Now, a kilonova is a different kind of explosion, triggered by the collision of two neutron stars or a neutron star and a black hole. When these incredibly dense objects merge, they release a burst of energy, which powers the kilonova explosion. Kilonovae are particularly interesting because they create heavy elements like gold and platinum during the explosion. One of the most significant kilonovae observed was detected in 2017, known as GW 170817. This event was extraordinary because it was the first time scientists observed both gravitational waves and electromagnetic radiation from the same cosmic event. The merger of two neutron stars produced a kilonova that emitted a burst of gamma rays. Follow-up observations across multiple wavelengths revealed the production of heavy elements. This discovery provided crucial evidence for the theory that such mergers are responsible for creating many of the universe's heaviest elements. So, how does the energy of a kilonova compare to that of a supernova? Well, kilonovae, while impressive, release significantly less energy. A kilonova might release around 10 to the power of 42 to 10 to the power of 44 joules of energy. That's still a lot by human standards, but it pales in comparison to the typical supernova. To put it into perspective, supernovae can be up to 100 times more energetic than kilonovae. A kilonova is like a powerful explosion, but a supernova is a cosmic cataclysm. In summary, while kilonovae are fascinating and essential for understanding the universe, especially in the context of element formation, they are not as powerful as supernovae. The energy they release, although vast, is much less than what we see in the explosive death of a massive star. If you found this comparison interesting, don't forget to give this video a thumbs up and subscribe for more cosmic insights. Until next time, keep looking up.